Good morning, everyone. I hope now my voice is clear to you. So, in the last lecture, we have gone through different technical terms associated with our data mining tasks. And the first fact that we have discussed are regarding different attribute types. And out of them, we have selected few very important attributes like binary, and there also we have seen symmetric and asymmetric, then nominal, then we have ordinal, continuous, discrete, this type of different attributes we have discussed. Now, let's come to today's discussion. The first thing that I want to discuss about the categorization of classifiers. So, classifiers are mainly categorized into two major types. The first one is discriminative, and you know this is a very basic classifier and it determines just one class for each row of data, and it tries to model just by depending on the observed data, and it heavily depends on the quality of data rather than its distribution. So discriminative data type focus only on the quality of the data. One such example of discriminative classifier is logistic regression. Let's take an example. See, acceptance of a student at a university, tests and grades needs to be considered. Say these are a few records. Student 1 getting 9 out of 10, grades 8 out of 10, and result accepted. Student 2 getting 3 out of 10, grade 4 out of 10, and result rejected. And student 3 getting 7 out of 10 and grade 6 out of 10 and result to be tested. These are the data. Now we have plotted them considering these two axes, x-axis for test and y-axis for grade. And then you will see these are the points. So when you see this green dot, these are the values where test score is C. If you if you look at the grades, you will see that when it is what greater than equal to 8, grade is greater than equal to 8, then we are getting what accepted result. And if it is 4, then it is rejected, and if it is 6, then result to be tested again. So in this plot, you will see that student T, say suppose grade test 7 out of 10, grade 6 out of 10. So this is the particular point, and it lies in this side, and this is the part. This line is dividing these two categorization or two classifications. You can say two classes. One side you have the students who have uh, been accepted for the admission, and one side we have those students who have been rejected. So as we see that student 3, its test value is 7 out of 10 and grade is 6 out of 10, so the student gets accepted, right? Similarly, 3 points, suppose this one is the point which is getting 2 out of 10, then he or she is rejected. Clear? So this is a kind of discriminative. This is very discrimination type, means it always tries to determine one class for every row. And what we have discussed is logistic regression is one such discriminative classifier. Then another thing is the generative. It models the distribution of individual classes and tries to learn the model that generates the data behind the scenes by estimating assumptions and distribution of the model. Okay, now here we try to focus on the distribution. Do note that in case of discriminative, we are focusing only on the quality, not on the distribution. Now in generative, we are focusing on the distribution, and we try to predict some unseen data. And one such example of generative classifier is NaiveBayesClassifier. It's a very important one. And this NaiveBayesClassifier is frequently used for one problem, and this one is detecting spam mails by looking at the previous data. So we try to detect spam mail using naive-based classifier. Let's take an example. Suppose 100 emails, and we have 100 emails, and we divide it into 1:4, that is class A, sorry, 25%, that is spam emails, and class B, 75%, they are non-spam emails. Now say a user wants to check that if any email contains the word ship, then it should be termed as spam. What it means that if an email contains a word chip, then it will be regarded as spam. And it seems to be that in class A, that is class A means what? Spam email, that is 25%, right? 20 out of 25 emails are spam. So this means that the chip word presents in 20 out of 25 emails, right? And in class B, we have 75% of data. Whatever the data, we are dividing 25% to spam and 75% to non-spam. Spam class A, non-spam class B, right? And in the class B, we got 70 out of 75 emails are not spam, right? And the rest are spam. So first questions that you try to solve that if the email contains the word chip, what is the probability of it being spam? I'm repeating again. If the email contains the word chip, one email comes and it contains the word chip, then what is the probability of it being spam from the given data? Okay, you try to solve it by yourself. It is very easy. It is very clear from the given data. Let me tell you the answer. Answer will be 80%. Okay, but you will do your copy pen and you will show me and you can post in the comment also. Now, the base classifier is clear to you. Okay, so probability based classifier, and now we have discussed both of them, that is discriminative, under which we have logistic regression as an example, and generative, under which naive-Bayes classifier as an example. Now, different classifiers means different frequently used classifiers we do have in machine learning or data mining are they are decision trees, Bayesian classifiers, neural networks, k-nearest neighbors, support vector machines, linear regression, and logistic regressions. So we frequently encounter any of such classifier for our classification tasks. They are very important. As a PhD scholar, I would like to suggest that you need to go through each of this algorithm in details, through theoretically and also through practical wise also. So let's come to the first one, decision tree. Decision tree is a structure that includes a root node, branches, leaf nodes. Got it? Obviously, if it is a tree, it will start from a root. Then we do have some other nodes, and then they are internal nodes, and then we do have those connection as branches, and the last nodes, which do not have any child, are leaf nodes. And each internal node denotes a test on an attribute, and each branch denotes the outcome of a test, and each leaf node holds a class label. Do note it, right? Each internal node means test, each branch means outcome, and each leaf means class level. So let's construct a decision tree for the very well-known example that we have discussed many times, that is the concept buy computer, that indicates whether a customer at a company is likely to buy a computer or not. And that will be our decision tree. See, S, if he is or she is young, and again, test is conducted in the internal node that whether student or not. If it is student, then branch is giving the outcome that what? Yes, he is or she is student of young age, then he is probably going to buy the computer. So yes is the class level. They are the leaf nodes. See, no, yes, no, yes, they are the leaf nodes. And branch, yes, no, and internal nodes, they are conducting tests. So one time I am repeating again. Say S is middle age. Oh, yes, if he is means giving some time to visit your computer shop and of middle age, so probably he is definitely or she is definitely going to purchase your computer. So class level is yes. Then S senior, credit ranking. If fair, then no. But if credit ranking is excellent, yes, he or she is going to buy the computer. So this is the decision tree for your buy computer problem, right? So what are the benefits we do have? It doesn't require any domain knowledge to construct a decision tree. It is very easy to comprehend it, and the learning and classification steps of a decision tree are very simple and fast too. Okay, so about the disadvantage, you may give me one disadvantage of decision tree. Let me tell you, when the problem is very big and the decision tree goes on means growing again and again, then some problem might also occur. What is